Why don't we go ahead and get started? Thank you all so much for joining us today for our symposium. I am looking forward to the conversation that we're going to have. Let me share my screen. Can you see the correct presentation view? Okay.
Yes.
All right. So our symposium today is titled International Perspectives on the Home Mathematics Environment, Variability in Relations, Measures, and Across Grades. So I will be presenting first, and then we will hear from Inés, Susperreguy, and then Cléa, Girard, and Joanne LeFevre will serve as a discussant today. So we're very excited. And feel free to post questions in the chat throughout, but we will have time for questions at the end. All right, so today I'm going to talk to you about a study that we have been working on that came from the Home Math Environment Conference that Dr. Purpura led. So this study is assessing the measurement of the home mathematics environment across countries in the TIMSS 2019 data set. So to give you some background on the study that I'm going to present to you today, we know the home math environment has shown a small yet significant relation to children's mathematical understanding. This correlation coefficient of 0.13 comes from a recent meta-analysis. And much of the research examining the home math environment is actually comprised of limited perspectives from countries that are often overrepresented in the literature. So from that meta-analysis, we found that they found that the home math environment data mainly existed from countries such as Canada, Germany, Italy, China, Chile, Australia, and the United States. And there are many more countries in the world, and so we want to think more about the different countries that aren't currently represented in the literature. So the current study built upon a recent call for expanding the measurement of the home math environment to include more diverse and internationally representative populations. And something to keep in mind here is that it's important to not only diversify participants, but also consider how survey questions that may have been written from those limited perspectives may operate differently in different countries. So perhaps some home math environment activities aren't actually relevant to families in different countries. So the goal of this study was to test to what extent there are international differences in parent reports of the home math environment. We had three main research questions for this study. So the first was, do families across countries differ in how frequently they participate in mathematical activities in the home? The second was, do the home math environment survey questions demonstrate acceptable reliability across all countries? And then the third was, how does the overall home math environment relate to fourth grade mathematical achievement across countries? To answer these questions, we leveraged data from the Trends in International Math and Science Study, the most recent WE.I.R.D. And this is a great data set because it has both math and science outcomes for 64 countries. In our case, though, the parent report survey was a voluntary piece of the study, and so only 54 of those countries actually participated in the part that I'm going to talk about today. And notably here, England and the US did not participate in the home environment survey, and so they will not be shown here in the results today. And they're not in the TIMSS data set. We had a decent sample size of parents reporting on children, and then we also had children's math achievement at fourth grade, so they were about 10 years old. And there are two main measures that I'm going to talk to you about today. So the first is the home mathematical environment measure. This was from the TIMSS Early Learning Survey, and it was parent retrospective report on 9 items. So parents were asked, before your child began primary or elementary school, how often did you or someone else in your home do the following activities with him or her? So parents are reporting on these questions from primary or elementary school when the children are already in fourth grade. And you can see that they're across the 9 items. These are items that we often talk about for the home math environment, like count things, write numbers, draw shapes, play board or card games, and weigh or measure things. These are, we typically see these across most studies. And then the second measure that I'm talking to you about today is children's math achievement. So this was the TIMSS IRT-based fourth grade math assessment. It's been well established, and this is all publicly available, so you can read a lot more about this measure specifically at their website. All right, so for our first research question, do families across countries differ in how frequently they participate in mathematical activities in the home? I first looked at the item averages across those 9 questions and saw that count things was actually the most common activity across all 54 countries. And then weigh or measure things was the least common activity. I will note here that the survey was a 3-point scale, so parents either responded 1, never, 2, sometimes, or 3, often. So there wasn't a whole lot of variability in the responses, but interestingly, and something that I'll point out throughout the rest of this presentation, is that you can see by the minimum and the maximum responses here across countries is that each of them are about a point apart. So even for the count things, there were still countries that responded on average 1.95 rather than the 2.55. All right, so this is a graph of the countries, the 54 countries on the x-axis by their average home math environment score on the y-axis. And it's going to be a lot, but we're going to walk through it. So here's the graph of each of the countries, and you can see that there is some variability, but there wasn't actually as much as I had expected there to be. So just as a reminder, that 1 is parents responding never on average, 2 is often, and 3, or sometimes, and 3 is often. And on average, the total across the 54 countries, parents responded to engaging in these activities between often and sometimes. So this was rather surprising to me, but I think it also may be limited in the fact that we only had 3 potential options for parents to respond to. We may more variability if they could have responded on a different Likert scale. Of note here as well, you can see that families in Morocco engaged in home math activities the least often. So they were actually the only country that was below that sometimes benchmark. And then families in Northern Ireland engaged in home math activities the most often. So they were the highest reporting country. And these 2 countries were significantly different. All right, the second question, do the home math environment survey questions demonstrate acceptable reliability across all countries? So again, we have countries on the x-axis and Cronbach's alpha on the y-axis. And here we actually saw that all countries demonstrated acceptable reliability across the 9 home mathematical environment survey items. But again, on average, they were actually around 0.79, so higher than that 0.7 acceptable reliability benchmark that we usually use. But again, there are still countries that are notably different. So we have Italy, Kosovo, Oman, and Georgia, where the home math environment survey items were acceptable, but still the lowest Cronbach's alpha. And then Turkey had the highest, or demonstrated the highest Cronbach's alpha with an alpha of 0.90. All right, and third, how does the overall home math environment relate to children's 4th grade math achievement across countries? So again, on the x-axis, we have country, and on the y-axis, we have the correlation coefficient. And I think you can guess that none are going to be above 0.45. But here we see a lot more variability in how the home math environment was relating to children's math achievement. So on the meta-analysis that I mentioned earlier found an average coefficient of 0.13, and in our study we actually found an average coefficient of 0.15. So these are really, really similar. But what I want to really drive home here is the fact that these are very, very different. The average does not tell the whole story here, and As you can see, children in Turkey and Bulgaria demonstrated the strongest relation between home math activities and achievement. So that correlation coefficient was 0.41. And then children in Georgia demonstrated the weakest correlation between home math activities and achievement, and that was 0.02. So although significant in this large sample, that effect size is really, really small and very close to 0. So something to keep in mind. And again, here, something that I also want to point out is that 0.15 average, really only 2 countries were at that. And this is why averages are so interesting and great, but also difficult, because really it only captures the story for Montenegro and Spain, and whereas there are many, many countries above that average and many, many countries below that average. A few key takeaways. First, we found that families in certain countries did engage in home math activities more frequently than families in other countries. Interestingly, all countries demonstrated acceptable internal consistency across the 9 home mathematical survey items. And although the average relation between the home math environment and math achievement was similar to the prior meta-analysis, what I do want to drive home here is that there was a substantial variation across countries, so that almost 0 effect to a pretty strong 0.41 effect is important. So I think what this study does is highlights the importance of really understanding variation and international differences, and provides a lot more questions than I think it does answers. I want to thank you so much for being here today, and thank you to all my collaborators. And I did make these slides available on OSF if you would like to go see them again. Thank you. I think we do have maybe 1 minute for a question, and then we'll move on. I think we'll have some time for questions at the end as well.
Hi, very interesting talk. I have one question about the variability across country. When you talk about, like, I think this study is very interesting in the perspective of trying to understand these variations across different countries. But I wonder if you thought about how the relevance of different types of math learning activity at home at different countries might be different. And did you look at correlations between different items with math achievement across countries?
I did not do the individual item correlations. No, that's a great question. I could do that, but I think something that you're picking up on is that, like, those big differences in the home math environment relation to achievement may be tapping into differences in how they believe, how different countries believe parents should be involved or schools should be involved in the development of math skills. And that's definitely an area of future direction that I would like to pursue. But I have not looked at the individual item correlation, so that could be something that I do. Thank you.
Yeah, thank you. Yeah, I think it's also like the variations of whether some countries involved in certain types of activities not captured by these questionnaires might be something to explore too.
Yes, yeah, definitely.
Very interesting. Thank you.
Thank you.
Can I ask you just a quick clarification question? I'm sorry, I was a couple minutes late, so I think I missed the first couple of slides. Could you just tell me what the sort of age range was for the kids that you were talking about?
They were 10 years old, so they were.
Okay, great. And so this sort of leads me, and maybe we'll get into this in other talks, but I'm curious as to sort of your thoughts on, like, the context of schooling versus parents at that age, and whether the sort of relationship might be more quote unquote universal across countries when they're much younger before they enter formal schooling, and the variability across countries and schooling might be driving a lot of this difference.
Yes, that's a great point. And something that you also may have missed if you missed the beginning part is that this was parent retrospective report. So it's parents reporting when the child is already 10 years old back when they were, like, estimating to when they were about 5. So that's another limitation here. So the strengths of this data set are that there are so many countries to talk about, but there are definitely some limitations. Thank you, Andrew. That was great.
Thanks.
Mané, I can hand it over to you.
Thank you, Alexa. Could you confirm that you can see the slides, please? Okay, thank you. Thank you, Alexa, and thank you for the invitation. So today I'm going to present a work that has been done with the collaborators that are listed here, and it's about the home mathematics environment and math outcomes in Chilean children in two groups, kindergarten and early elementary school children. As it was mentioned in the prior talk, the home mathematics environment includes activities, resources, and opportunities that parents provide to support their children's mathematics learning. And today I'm going to talk specifically about the home mathematics activities. And research has distinguished between different types of activities, specifically formal activities and informal activities. So formal math activities are those activities in which parents engage in with children at home with the focus or with explicit teaching focus. So they are interested in for the children to learn mathematics, so they teach mathematics in different activities. And we have distinguished between mapping activities and operational activities, and mapping activities are those in which parents and children engage in different ways of representing numbers, for example, counting numbers, printing numbers, and on the other hand, operational activities, which are activities that involve operating on numbers and quantities, for example, doing mental math. Additionally, other research has shown that informal math activities are other types of activities that are related to mathematics performance, but those activities do not have the intention of teaching math. So mathematics learning is incidental. For example, when parents engage in board games with their children learn mathematics, but that's not the goal of the activity. Most of the studies on the home mathematics environment have concentrated on children in kindergarten or preschool, but less studies have looked at what happened with the home mathematics environment of children in primary school. It could be that the home mathematics environment of children in primary school is different, that the experience that children have with the parents vary depending on the assignments of the school, or maybe other factors play a different roles. For example, the socioeconomic status, the instruction of the school, the conditions. And we were really interested in seeing whether parental variables, specifically mathematics fluency and educational attainment of the parents, were related to math performance at that age as well. So the aims of the study that I'm going to present are evaluate the relations among the parental factors that I was mentioning, the math fluency and educational attainment, school socioeconomic status, the home mathematics environment, and children's math performance in both kindergarten and grades 1 and 3. We were also interested in seeing whether the home mathematics environment activities, formal mapping, operational, and informal activities predicted children's math performance in both groups, kindergarten and grades 1 and 3. So we assessed parents and children. We went to the homes to evaluate parents, and we assessed children and students in their schools. So at home, parents self-reported activities based on the Spanish version of the Skwarchuk et al. Questionnaire that we have used in prior research with Chilean students and with Mexican students as well, children. The questionnaire included formal operational home math activities for items such as, for example, doing mental math or others about math operations. Informal home math activities was assessed using a number game checklist that adapted also from the work by Skwarchuk et al. And we have used this instrument with Chilean students in prior research. And mapping activities, which are activities in which parents and children identify and represent numbers, or they focus on determining quantities. Parents also provided sociodemographic variables, their socioeconomic status and educational attainment, and completed a math fluency task. This is a subtest of the Goodcock-Johnson test of achievement. It's a 3-minute task in which parents solve simple calculations. Children's measures included 3 subtests of the Woodcock-Johnson math subtest: the calculation, applied problems, and math fluency. For the calculation subtest, children had to write down the answer of mathematical calculations that are presented on a paper, and the questions increase in difficulty so that they are stopped after a certain amount of errors. For the applied problems, children have to solve math calculation problems that are presented verbally, and most of the time that is accompanied by a visual stimulus, usually a picture, and problems become more complex as well. And finally, the math fluency task, which is the same that parents answered. And this is a simple arithmetic calculation task that is a 3-minute task. So what we did, first, we created a single math outcome variable for each group of children. For kindergarten children, we were able only to include calculations and applied problems tasks. The math fluency was very difficult for children at this age. For grades 1 and 3 students, we included the calculations, applied problem, and math fluency as the outcome, as a single outcome. So I'm going to present some descriptive statistics, mainly correlations, to evaluate the relations among parental factors and school SES, home mathematics environment, and children math performance. And finally, I'm going to present multiple regression analysis to show you how the home mathematics activities were related to math performance in kindergarten and grades 1 and 3. I want to highlight that the analyses were conducted separately for mothers and fathers, so I'm going to present the results in that way. So in terms of the relations among parental factors, the school SES, the home mathematics environment, and math achievement, it's important to highlight that for both groups, for kindergarten children and grades 1 and 3 students, mother's education, father's education, and school SES were highly correlated. School SES was significantly, I'm laughing because I just realized that I skipped the participants slide. I don't know why, but I can show you that information right away. I'm sorry. I may have hidden it without noticing. So school SES was related to children's math outcome in kindergarten and grades 1 and 3. No relations between gender and math performance. And parents' math fluency was related to the educational level. Give me a second. I'm sorry about this. Oh. Let me see if I can get back to the. Yeah, because I wanted to. Okay, see, this is a participant. So I wanted to highlight, I'm sorry about this confusion. The participants were parents and children were in both kindergarten or either grades 1, 2, and 3. And for each child, a female and a male parent answered the question separately. Sorry that I'm saying this at this point. I don't know why I skipped it. And the parents were recruited through 5 schools children were attending, and the schools were coming from low or high socioeconomic status groups in Chile. That's important to mention because in Chile, the educational level of the school is related to the socioeconomic level of the students. The schools are highly segregated. Okay, so now some of the results make more sense. Sorry about that. Okay, so now I'm going to show you the part that I found that respond to the final questions that we have. So how these home mathematics activities were related to the performance in kindergarten and grades 1 and 3. So first, I'm going to show you the results for mothers. Our regression analysis were conducted using 3 models. So in the first model, we included school SES, the grade by gender interaction, and the child's gender. We also included the grade in school for the group of grade 1 and 3 students. And in this first model, you can see that for kindergarten children, as expected, school SES was positively related to performance. These are the results reported by mothers, but this is the demographic information. In terms of grades 1 and 3, Similarly, school SES and also the grade by gender interaction. As expected, the grade of the children was related to their outcome. In the second model, we added the parental variables, specifically parental education and parents' math fluency. And as you can see here, for the kindergarten group, there was no positive prediction, but for the grades 1 and 3 group, in addition to the variables we already mentioned, maternal math fluency was positively related to the outcomes. And in the final model, we added the math activities variables that we were interested in, the shared number gameplay, the mapping activities, and the operational activities. And for the kindergarten group, you can see here that the mapping and operational activities were related to the outcomes in the children, negatively related in the case of mapping activities and positively related in the case of operational activities. For the grades 1 and 3 students, in addition to the other variables that we mentioned, there's no prediction from the home mathematics activities to the outcomes. Now I'm going to present you the results based on the reports by fathers. So the first part is the same that we just saw about the demographics. When we added the parental variables, you can see that none of them is predicting outcomes in either group, kindergarten or grades 1 and 3. And similarly, when we look at the parental variables related to the home mathematics environment, there's no relation among them. So in conclusion, the home mathematics environment, as reported by mothers, was related to children's math outcome, controlling by the other variables. But for children in grades 1 and 3, the home mathematics activities reported by either parent were not associated with performance in this group of Chilean children. Instead, school socioeconomic status and mothers' math fluency were related to children's math skills in the primary school years. And the father's variables did not explain variability in the outcomes in kindergarten or grades 1 and 3. So the patterns of the results for kindergarten children were consistent with prior research and with the research presented in the meta-analysis, but no relations were found for older children. Why this was the case for the kindergarten children and not for the primary school children is an open question that we believe needs more research. We think that it's critical to account for the instruction, the mathematical instruction that children receive in school, but also would be important to target additional forms of parental support. For example, activities that are more aligned with school requirements or maybe assessing homework help. We also believe that conducting longitudinal research and maybe using other questions or methods of research to collect additional information would provide us with more information to understand these differences. So I would like to highlight that this was done in collaboration with other people in Chile, with collaborators in Canada, and I would like to thank you, coordinators, research assistants, schools, and the funding sources. Thank you.
Great, thank you, María. We have time for 1 or 2 questions.
I do have one question.
Yeah, Cléa.
Thanks for the presentation, very interesting study. Did you adapt the items, the questionnaire items to the child's group, like for the youngest one and the oldest one?
Oh, thank you
so
for the question.
They were the same items or not?
Yeah, so that's a great question. And I did not mention it. I'm sorry about that. But kindergarten children, for the kindergarten children, we use the same questionnaire that we have used before. But for the older children from grades 1 and 3, we adapted the questions to make them more difficult and more aligned with the developmental trajectory and the instruction that they have at school. But in order to assess these activities, we ask the same questions from grades 1 and 3. So that's, I think, another line of research to look at specific things in each specific grade. So for example, we were not able to include questions about multiplications or fractions here that were asked to older children because they were not asking younger children because it doesn't make much sense.
And if you look at grade 1 only, did you have any effect of the question of parental activities?
We haven't looked at specific items. I think that that's an interesting avenue as well.
Thank you.
I have one quick question. I'm not familiar with the literature, I guess, that's starting to emerge about the difference between caregivers. And I'm wondering whether sort of how you approached it, looking the differences between mothers and fathers. So one instance I can imagine is that if we go with this sort of standard, and I'm not sure what it is in the sample, but if we go with the standard that mothers might be the primary caregiver, that there might just be overall less variability in the father's like environments that they're interacting with their kids. And so that might be one of the issues with the data, is that it's just harder to detect the subtle effects. And so I guess there's sort of two parts. One is that, are there differences between the two parents and like the degree to which they're engaging with their kid in the environment? And two, is there a way to sort of tease apart, if the father happens to be the primary caregiver, is it about the primary caregiver that is the person rather than the mother or father per se?
Thank you for the questions. These are very, very interesting points. First, indeed, there were differences between mothers and fathers in terms of the engagement. In general, mothers engage more activities than fathers. I would say in general, there were a few exceptions, but in general, mothers were more engaging than fathers in activities with their children. But there was variability. I mean, there was variability in both groups. Some research has shown that fathers sometimes engage in other types of activities, more informal activities. In our case, we did not find that difference or that effect. I think that it's important to highlight that this research was conducted with Chilean students, and in Chile, mothers usually take care of the kids most of the time. I think that's important to mention, that statistics at the national level indicate that students and children spend more time with mothers at home. But I definitely think that this is an important point to better explore, because I think that the fact that these variables that we assess do not relate to children's outcome doesn't mean that fathers are not doing anything important. It means that the variables that we use or the things that we measure. So I'm very interested in exploring what other aspects of paternal engagement would be related to outcomes in students at this age.
Thank you.
All right, thank you so much, Renee. Cléa, I can hand it over to you.
Is that okay?
Yep.
Okay, so hello everyone. My turn to thank Alexa for organizing this symposium. So I'm going to present a pre-registered study on the relation between home math environment and children's math skills, a study that we did during my thesis under the supervision of Dr. Jérôme Prado. So we wanted to carry out this study according to the existing hypothesis on the home math environment literature, to provide a theoretical model to test. So first, for the home math activities, according to the distinction proposed by Joanne LeFevre and collaborator, which consists to separate informal from formal math activities. So as previously mentioned, it depends on the presence or the absence of an explicit teaching purpose. For example, informal math activities could be cooking and measuring ingredients, or playing a board game with a numerical dice. And formal math activities could be asking the child to count up to 20 or to solve additions. Skwarchuk and collaborators have then suggested to complete this distinction by further separating formal math activities depending on the level of complexity, challenging or not challenging children math skills. So either basic formal math activities or more advanced formal math activities. For example, for a 5-year-old, basic formal math activities could be reading numbers up to 5, and the more advanced formal math activities could be reading numbers up to 20. It also proposed that each kind of home math activities would be associated to different math skills in children. So informal math activities would be more associated to non-symbolic math skills in children, while formal and especially advanced formal math activities would be associated with symbolic numerical skills in children. Some studies have also suggested theoretical links between parental math talk and children math skills. However, as already mentioned, reviews of the results obtained through experimental studies revealed more mixed results. So I'll unpack potential reasons for this heterogeneity. One of the potential reasons could be the wide variety of methods employed across experimental studies to assess the home math environment. For example, for home math activities, different questionnaires have been used with a very important disparity in the number of items used to assess each kind of activity. Some questionnaires contain very few items and others contain several dozen. Additionally, scores for each kind of home math activities have been calculated differently through experimental studies. And the same heterogeneity exists also for the language recording used to measure math talk. Very different situations have been used to record math talk, either at lab, school, or home, with different duration and less or more standardization of the situation. And different indices of quantity or quality of the math talk have been measured. For example, the size of the number, of the context of the number talk, for example, cardinality context. So all of these methodological disparities could lead to some relatively large researcher degree of freedom, which the pre-registration could help to reduce. Pre-registration allows to dissociate exploratory from confirmatory results. But to date, only one study on the home math environment has used pre-registered method, a very recent study by Marie de Pascal and collaborator on math talk. So the purpose of our pre-registered study was to test different main hypotheses driven from a home math environment theoretical model. So first, we wanted to test the relation between informal math activities and non-symbolic numerical skills in children. Our second hypothesis was to test the relation between formal advanced math activities and symbolic numerical skills in children. A third hypothesis was to test the relation between parental math talk and children math skills. A fourth and final hypothesis was to take into account the literature on the importance of different control factors in measuring these different relations between home math environment indicator and children math skills. So our pre-registered sample size was 128 5-year-olds and one of their parents. So they were in the equivalent of kindergarten in the French school system. Various math skills were tested in these children with a large battery. Parents completed a questionnaire assessing frequencies of informal, basic formal, and advanced formal math activities at home. And children and the parents did a 10-minute free play session at the lab to assess math talk. Children's IQ, parental math skills, with also an arithmetic fluency task from the Woodcock-Johnson, and parental education and income level were assessed as control factors. And to test our planned analysis, we predicted to make a correlation and a regression analysis to take into account the different control factors. So what about our confirmatory results? First, our data were inconsistent with the first hypothesis on a relation between informal math activities at home and non-symbolic numerical skills in children. We did not observe any relation, and our results support the null hypothesis with Bayesian statistics indicated a moderate level of evidence for the null hypothesis. Our second hypothesis on a relation between advanced formal math activities and symbolic numerical skills in children was consistent with our data. First, we did not observe any relation between basic formal math activities in blue and symbolic numerical skills in children, with a moderate level of evidence in favor of the null hypothesis. but we did observe relation between advanced formal math activities in red and symbolic skills in children, with a strong level of evidence for arithmetic skill and even an extreme level of evidence for transcoding skill. Our third hypothesis on a relation between parental math talk and children numerical skills was non-supported by our data. We did not observe any relation between children numerical skills and parental math talk. And Bayesian statistic indicates moderate level of evidence for the null hypothesis. Finally, our last hypothesis on the control factors was confirmed by our data for the relation observed between advanced formal math activities and symbolic skills in children. These activities remained linked to transcoding and arithmetic skills in children, even after taking into account children's IQ, parental math skills, education, and income levels. Finally, we also conducted some exploratory analysis with our math talk data. So as a reminder, as previously mentioned, we did not observe what we expected. We did not observe any direct relation between parental math talk and children math skills. However, as exploratory results, we observed that parental math talk was positively related to children math talk. And children math talk was also positively related to their arithmetic skills. So an unplanned mediation analysis indicated a possibility of significant indirect effect of parental math talk on children arithmetic skills through children's own math talk. However, it's important to consider that this mediation analysis was just a proposal to test the relation between these different variables. These results were completely exploratory and cross-sectional. So of course, it's not possible to conclude to any causal links here. So to discuss all these results, our study tends to confirm the importance to dissociate theoretically formal math activities according to their level of complexity, so basic or advanced formal math activities. Here we dissociate this level of complexity based on the French preschool curriculum. We did not identify any relation between children math skills and measure of either informal math activities at home with a questionnaire or parental math talk in the lab. This may raise some methodological issues, such as the difficulty for parents to identify correctly informal math activities on a daily basis precisely because of the implicit nature of these activities, contrary to formal math activities. And moreover, the situation of free play session in the lab could induce a significant desirability bias in parental talk, and this exploratory mediation results might suggest that children math talk could be less subject to the desirability bias than parental math talk. And finally, we believe that future research would benefit from distinguishing between exploratory and confirmatory results. Thank you for your attention. I would like to thank all the children and families who participated in our study. Thanks again, Alexa, and thanks to the lab member who makes this research possible.
Thank you, Cléa. We have time for one question if anyone has one right now. If not, I can hand it over to Joanne to be our final presenter and discuss it. Go ahead, Joanne.
See my slides. Okay, so thank you, Alexa, for organizing this symposium. It's always a pleasure to talk about the home math environment, although of course there are lots of questions left that we need to answer. I have a few remarks. I'll be quite short, and then I have a question for each of our presenters, and the questions are supposed to be hard questions, so to get us thinking and talking about the issues that have been raised. So I'd like to, in my brief remarks, talk a little bit about what we learned from these presentations. And of course, we learned many things, but in particular, I looked back at the very comprehensive review meta-analysis paper published last year by W.E.I.R.D and colleagues. And when I look back there, and they pointed this out as well, we have to realize meta-analyses are very important, right? Because they pull together a lot of information across a wide variety of studies. But of course, meta-analyses are limited by the data that they have. And although, again, it was a very comprehensive review, one of the striking things was all the kinds of limitations. So that suggests to us that we need more data. And I'm going to talk a little bit here about what the three studies we just, the three analyses we just heard might contribute, what kind of data they might contribute. So one of the issues that was mentioned by W.E.I.R.D et al. Was that we don't know much about older children in the home math environment. And so the two of the studies explicitly sort of look at that kind of question. In Ellis' study, the kids were in grade 4, although interestingly, the parents were retrospectively thinking about what they had done before the kids started school. And I think that's a really important distinction and something maybe we need to look at a bit more, and ties into the idea of doing longitudinal work as well. In Manet's presentation, which of course I was involved in that research as well, the whole point of it in some sense was to look at older children to see how the home math environment might be involved. And we were not anticipating the pattern of results that we got. We didn't think that's what we would find. And so this contributes to more information, even if it's not exactly what we perhaps would have expected. Another issue that was raised and is obviously critical for this field is to involve participants from a wider range of countries. Of course, Alexis' paper does that in spades. I mean, it's just like 54 countries, holy cow. That's great. In Manet's presentation, it includes more Chilean children, and I'll come back to some of the specific features of that study at another point. And in Cléa's presentation, I'm not sure how many other studies there are with French preschool children in the home math environment. I wasn't familiar with any, so that's like a whole new piece of information as well. So that's great. Another important factor is how the home math environment is described and measured. And in the W.E.I.R.D et al. Paper, they called those the home math components. And of course, given I was involved in the original model that Skwarchuk and I'll talk about, it's great when other people use what you've done. So it was very exciting for me to see that Cléa and her colleagues used the model and then pre-registered it, right? Because that is really important. It's actually the best we can do in these correlational studies in terms of testing models. So that was exciting. And of course, Manet's work was also based on the same model. So that I think is really helpful because it's trying to put the research on a theoretical perspective, something that I think we need a lot more of in this field. So that was great. Another important factor that came up in the meta-analysis, what I don't think that any of us have really addressed very well at all, is how does socioeconomic status play into the home math environment and into the patterns of relations that I've shown. Of course, in Alexis' paper, you can't really, I don't even know if those data would exist, or if they did, you're shaking your head, okay, so you can't, what can you do? On the other hand, for sure, the countries vary in terms of the level of socioeconomic status, right? So how to deal with that, not clear. In Cléa's study, you did what we all do, which is controlled for some of the obvious SES factors like parent education and income, which, I mean, it's not a solution. It doesn't tell us anything, but it's important to keep, at least we can gather information about that. And in our study in the Manet discussed, these children were drawn from two extremes in socioeconomic status, low SES schools and high SES schools. And I'm going to get, one of my questions is going to pursue that a little bit. But another difficulty with SES is it's different in different countries. So that idea that you can separate SES by school works in Chile And it might work in other countries as well, but in a country like Canada, that's not going to help you understand SES because that's not the way education works here. So this is a tricky one, and maybe none of us can really address it. So that's enough from me. I would like to hear more from our presenters. So I am going to stop sharing my screen so we can all see each other a little bit better. And I have 3 questions that I would like to, one for each presenter. So I'm just going to go in order. And as I said, I tried to make these hard questions, so they're not necessarily going to have a straightforward answer. So Alexa, you're first. And this was touched on in the question that you were asked. I want to know why you think there's so much variability across countries in the correlation between the HME and math performance. You referred to it, you mentioned how crazy it was. Why, what's going on?
Yeah, I think it's a great question. So this question could also be something that we may be able to start addressing with the TIMS data set because they do have school level information. But I do think that one of the key points here is trying to figure out how the responsibility of the parent and the responsibility of the school differ across the countries, and why that matters for the relation to math achievement. So whose responsibility is it to really train these skills across the different countries? And we know that countries should differ in this because we see it all the time. I mean, this differs also in the United States and even by state, and I think also by SES, Joanne. So I think the more you think about it, the more variability you can see within each topic. So country at large, depending on if it's parent or school, or even how they're training math, because we know that there are different ways to train math in school. And then also even within country and within different demographics in countries, there's a lot of variability. But it's a great question. And I think some next steps might be thinking about school instruction and how school instruction is training it, and then also maybe parent responsibilities and whether parents believe it is their responsibility to teach home math and the whole math environment, or if parents believe that. I think I've talked to Mané about this a few times, and Jimena, that some in Chile, some parents believe that it's the school's responsibility to teach these skills rather than the parents. And so that could be why we're seeing differential relations in the home math environment and achievement.
Okay, great. I can imagine the other presenters might come back to that a little bit, but I'm going to give everyone a chance to ask, to potentially respond to a question. So Mané, and this is a slightly unfair question because it wasn't really the focus of your presentation, but I would like you to comment on what you think you learned about how we should study the relationship between SES and the home math environment, or maybe what you would do next or differently or something.
Thanks, Joanne. I think there are several ways to answer that question. The first is that I have a look at SES in terms of educational attainment. And we know from David Skin's research that there are other aspects as well. So I think that it will be really interesting to look at not only educational attainment, but also resources that provide home or income and so on. I live in a society that is very segregated in terms of socioeconomic status. So that is a challenge for me to conduct research and looking at the home mathematics environment and children's outcomes. So I can't be blind about that. So I need to consider the socioeconomic status. So one of the things is that in prior research, I usually controlled by the SES of the parents, but in the research that I presented today, I was really interested in seeing how the home mathematics environment could be like an asset that could help specific groups to do better in mathematics. So that's what I was interested in these two groups. I think that I won't be able to do research without considering the SES of Chilean students. It could be that for younger children, that's not that prominent because most of the differences start to appear in school, because the schools are different based on the SES of the students. So I think that this is like, this is one from Brenner's type of model. So not only the society, but also specific things of the school and the parents, and made the model even more complex. So I don't know how to answer the research question that you said, Joanne, but those are the thoughts that I have. I definitely think that in order to keep doing this research, I need to consider more contextual factors in order to do this type of.
So maybe we need more thorough models. We talk about the math environment, but we're really only looking at little pieces of it often.
Yeah, and most of the research comes from societies that are even more homogeneous in some sense. So I think that in a society like mine, in which SES is pervasive in many senses, I can't do research without looking at that. So one thing that I really want to do is focus on specific groups that are in more need of helping with math skills at this point.
And that ties into what Alexis said as well, in terms of trying to understand what's going on in different countries, right? Because it is very different. Okay, I want to make sure there's time for Cléa to address a question as well. And so, great presentation, very interesting, but I'm going to ask you, so what are the next steps, do you think, for looking at informal home activities? Where would you go next with that, or would you not bother?
Yes, that is, yeah, because I think in fact, the more mixed results are for these informal math activities, but in the same time, we also have some interventional studies which have shown that informal math activities matters. We cannot say because we are not able to measure through the questionnaire that don't matter at home, because during study, asking parents to read books with number information, it works. It helps children to learn. So I really don't know if there is, because we wanted to try to record parents' math talk at the lab, like a way to maybe obtain information about this informal context. In fact, it doesn't work, not at lab, but I think we should consider other tools like the LENA, which has already been used. I think in your study, Mané, you used the LENA device record for like a more ecological way to register interaction at home. Maybe it's really the best way, but it's also more in, like, in France, it's very complicated to have agreement to lead a study like this, because it's really like seen like an intrusive study. So it's really complicated to have a sufficient ecologically good situation to evaluate this kind of activities that parents did without any explicit conscious of it. I think, like, I don't have the solution, but I will be happy to share any doubts.
I think there's so many reasons why it might be difficult to establish a measurement of the informal environment, right? Like it's just really hard. So playing into this idea of we need more complex models, perhaps we have to have, but we need to stand back somehow and think about it differently. When we first started thinking about this, it was coming from the home literacy environment, and there it's pretty simple because you read to kids, right? And that brings all kinds of language and stuff into the home. But we don't, that may be important for math as well. David's obviously been looking into that, but it can't be the only thing, right? There has to be more complex. Yeah. Okay, so I'm finished being the discussant. I know we're almost out of time, but I wonder, do we still have time for questions from the audience? Alexa, what do you think?
Yeah, we could take a few questions.
Go ahead.
Thoughts are also welcome. Doesn't necessarily have to be a question.
I'll keep talking if no one else has questions.
Great.
I have lots of questions. Thank you for all of the presentations. I've recently been reading a lot about the whole math environment and doing my own sort of work on this. And I think that you all are right that there are more questions than answers at this point. But something that I've been thinking a lot about is the role of socioeconomic status. And something that I've been trying to think about in a model I sort of have in my head is that the whole math environment is part of socioeconomic status rather than thinking about socioeconomic status as a separate thing. And so I guess in some of the work from like Martha Farah's group at Penn in thinking about how socioeconomic status affects neurodevelopment, they think more of, there's another sort of model that socioeconomic status is moderating the relationship between these rather than mediating it. And I think in my head, in this perfect world, like socioeconomic status is the thing that, you know, is mediating this maybe relationship. But I'm wondering, especially as I think about within the United States and the sort of stronger racial and socioeconomic disparities that happen along racial lines, I'm wondering how sort of that might moderate the relationship between some of these home activities and math achievement, and especially with your sort of findings, Cléa, about like how informal versus formal might be differentially affected by some of these socioeconomic environments. And I'm curious as to what y'all's thoughts are on how this might moderate it rather than sort of account for some of these differences in a full mediation model.
In fact, in my case, we tested this mediation model, but with another sample of 8-year-old children, and we did obtain something similar from like Farah model, or like from a mediation from socioeconomic status to children arithmetic skill through stimulation, formal advanced math activities only. That's always the same issue, that the only activities that we were able to measure correctly and have a significant relation with math skills. But yes, we tested this mediation model and it works. But it's also like for my own study, we did not target specific school. We recruited very various children from very various schools, but that's also an issue per se, because we did not control at all the school socioeconomic status. So it's always like it's also an issue to conclude that it's socioeconomic status of the parents and not socioeconomic status from the school, for example. And in France, we have specific politic targeted, very low socioeconomic status schools. So it's very difficult to identify correctly if it's really the parents' socioeconomics which matters. And in fact, we tested that because it was asked for by reviewers, but it was not the aim and the purpose of the study when we did the study. So it's very complicated to be able to dissociate very carefully the socioeconomic status of the school and from the parents. We did not target specific schools. So. But yes, I think it's really important to consider home environment, home math environment as more distal factors from the families and from proximal factors and socioeconomic status, other information, but distal information. I think it's a very powerful model to consider this as like just different levels of analysis from the family context. It's not the equivalent measures. We do not measure the same thing by assessing parent math activities and parental socioeconomic status, but both matters in a way because, yeah, I don't know if it's answered your question.
And I can just comment, Mané, you didn't highlight this in your presentation, but in fact, if we look for the analysis for the kindergarten children, initially, socioeconomic status was a predictor, but then when the home math environment factors were added in, it was no longer a predictor. So that's exactly kind of getting at what you're saying, right? Home math environment is part of socioeconomic status, and that seems like a very the moderating side of it seems like a good way to potentially start understanding that better. But again, it probably varies with country because it's just not the same across, like the work that María and I have done together. We talk about this a lot, like you can't even compare across countries like Canada and Chile is not even the most extreme example. So it's an excellent point and complicated. I agree with you, Cléa, it's complicated.
I just wanted to mention, listening to Andrew's comment, that developmentally, putting this on the scale, going back to Bronfenbrenner, thinking about what is the role of SES in developing an environment that a child in the United States grows up in, 0 to 5. Then you transition to the schooling, and what does the schooling add to the math knowledge all the way through high school, which in our country kind of dictates whether you go to college or not. So it's a complicated question, and SES is intergenerational. So it's not like it just shows up in the one generation for the kid. It's something that's carried over, which also means the value you put on training in the home also carries over. So I think it goes to this bigger model. We've spent, literacy has a lot of models because they've been looking at it a long time, and math doesn't. And I think math, unlike reading, where we had huge interventions in the United States, like decades ago, for people to read to their kids, we haven't had anything similar like that in math. And I think it is because we have this kind of assumption that math will eventually be taught in the schools, where we think that parents should read to their kids because that increases language. And so we've kind of made math different, even though the symbolic skills of learning how to read or language is similar for math. So I think it really is thinking about these models that, and taking into consideration internationally how these models will differ because of the values that parents or cultures have, or the limitations cultures have on how they provide things in the home, or the role that parents or schools have. And I think that's what makes this area so interesting, is really trying to understand those differences, because you get into the high SES in the United States, probably because you have been somewhat successful at math, because it dictates who goes to college in the United States, because it's not reading that gets you in to a 4-year college, it's really your math scores that get you into a 4-year college. So it's really kind of a complicated, interesting thing to figure out. But I do think we have to think of it in this, does it moderate, does it mediate? The answer is probably yes, to both of those. It just depends on the question that you're looking at.
Yeah, I completely agree with you, Pam. And I think like a little anecdote from when we first started doing this research, so that would be 15 or so years ago. And the very first paper that we published was the 2009 paper that went through 4 different journals before it got published. And so we got lots and lots of feedback, most of it negative, obviously, or it wouldn't have taken 4 journals. But one of the things that the reviewers said was, kids learn math in school. Why do we care what happens at home? And I mean, I was kind of shocked by that, because I was coming from the home literacy kind of research where everybody completely accepts the idea that what happens at home. It isn't even like it's a controversial point to make. And so I think you're completely right. Like it starts that early that some people just think it doesn't even matter. It doesn't even make any difference. And yet we know that kids come to school with huge differences in their preparatory math skills. So clearly we need to understand this better.
I just want to add to Dr. Keen's comment on the Bronfenbrenner model, because I was thinking the same thing. This is just an anecdotal experience that I had when I was working in India as a Teach for India fellow, that in the low socioeconomic status, because we worked with underprivileged children, math was given a lot of importance at home. Like when they used to go back, the next day used to come and they didn't used to do any homework for history or civics, but their math homework was done because their parents were like, oh, you have to learn math. And I think maybe that's where the culture and just the idea that math is important financially as well is important. Whereas in the high SES in India, usually all the subjects, like while math and engineering were really important, but parents were also open to subjects like art and literature. So it's really interesting to see how like culture also plays a lot of role in the home math environment. So just wanted to comment on that.
Thank you. That was a great addition. So I feel like we are over time, but I want to thank everyone for coming today. Mané and Cléa, great presentations, and Joanne, thank you for a great discussion. And everyone else who jumped in. I think we've left with, again, more questions than we have answers, which is always great for our field. We have many future directions to pursue. And I think this is just a reminder that one size does not fit all, and we need to really focus on these differences internationally and by different demographics and by different grades. So thank you all so much and have a great rest of your Thursday. We'll see you next week.
Thank you. Bye-bye.